Students, welcome to YouTube channel Vidya for Success. Dear students, in this video, let us try to analyze or try to study how to convert these data to a table. So, these are the data of 50 students of a college. So, in a college there are 50 students. This data is of their weights, 50 students, different weights. So, you cannot analyze these data if they are presented in this particular format. So, the best way to analyze them is to convert them into a tabular way. That is, you need to convert them into frequency distribution. So, frequency distribution will be of two types. One is discrete frequency distribution and the one is continuous frequency distribution. So, let us convert these 50 data into continuous frequency distribution. So, but before converting them, we need to study a concept called principles of classification, or also called as rules of classification. Nothing but simply we cannot classify a data according to each one of our taste and preference. There need to be a particular rule which everyone should adhere. So, here also there are certain rules. So, what is the first rule here? The first rule says that the number of classes should generally between 4 and 8. So, we will be putting forward all these 50 data into a particular classes, into class intervals. So, how many classes we can have? We can have classes between 4 and 8. It should not exceed 8 and it should not come below 4. Okay, it can be between 4 and 8. So, that is the first principle. Similarly, the second principle says that exclusive classes should be formed for better continuity between the class intervals. Already you know there are two types of classes, inclusive class and exclusive class. For example, 0 to 9, 10 to 19, 20 to 29, these are inclusive classes. Both lower limit and upper limit are included in the same class. But if you go with these type of class intervals or classes, it will be not easy for you to study of continuity. So, better always you consider continuous, exclusive classes. So, that is 0 to 10, 10 to 11, 10 to 20, 20 to 30, like this, where lower limit will be considered in the same class interval, but upper limit will be considered for the next class interval, that is succeeding class interval. Okay, so we should not go for inclusive classes, always we should go for exclusive classes. That is the second thing. We should always, for continuity's sake, in order to study the problem in a fair way, we should go with exclusive class intervals. Next, the third principle says that the width of the class should be kept constant. So, please notice here, I have considered class intervals 0 to 10, 10 to 20, 20 to 30, like that. So, always this width, that is the CRI we say it as. Okay. So, this width should always be a constant one. For some class interval, if we consider 10, for another 5 or 15, like that, it is not a good way of projecting the data. Always there should be a constant width. Similarly, the fourth one is, as far as possible, avoid open-ended classes. If there is an open-end class, then it does not convey a proper meaning. For example, in the place of 0, if I say below or less than, I will be using less than 10, it does not convey anything. Less than means what? Whether it is minus 5, minus 100, what is the value? We do not know. So, as far as possible, we should not go with the open-end classes. That is the fourth principle, fourth rule. Similarly, the fifth rule or fifth principle is, the classes should be arranged in a particular order. What is that order? Either it should be in ascending order or it should be in a descending order. For example, 0 to 10, 10 to 20, 20 to 30. So, here is an ascending order. But instead of it, if you go with like this, for example, 20 to 30, here you are considering 0 to 10, here 30 to 40, it is not a good way of projecting the data. So, always the classes should be either in ascending order or it should be in a descending order. Similarly, the fifth last principle or rule of classification says that the lower limit of the first class should be multiple of 5. That is, let us say I want to project all this data in a class interval. I will be starting with, let us say, 5 to 15, followed by 15 to 25 or 25 to 35, like this. This is one way of projecting. Or else I'll be going with 0 to 10, 10 to 20, 20 to 30. Okay, this is okay, fine. Because all these lower limits, the first class lower limits, they are multiple of 5. On the other hand, if you go with lower limit like this, 3 to 8, followed by 8 to something 13, like this is not a good way. Always the first lower limit value should be a multiple of 5. Okay. So now with these principles or rules of classification, let us convert these data into a continuous frequency distribution table. Okay. So for this, in order to classify them, in order to convert them, first of all, we would like to know what is the smallest value. That is, we need to know smallest value and highest value in order to know what is the range. What is range? The formula for range, the range is highest value minus lowest value. Okay, so what is the smallest value, highest value here? So the highest value here is 64 is the highest value. Okay, so the highest value is somewhere here 64 is the highest value. Similarly, the lowest value here is 32 is the lowest value. So what is the range? 64 minus 32, the range is 32. The range is 32. So first we will be finding the range, followed by this. Now we need to decide how many classes we need to go with. So how to know how many classes we can consider for this particular data? So there is a rule given by Professor Struji. Okay, that is called Struji's rule. So what is that rule? K is equivalent to 1 plus 3.322 log n. This is the formula. So that is 1 plus 3.322. What is n here? N is nothing but number of observations. Totally how many number of observations are there? Totally we have 50 students data. So n is 50. Okay. So first we need to know what is log 50 value. Okay. So using the logarithmic table, you can find out what is log 50. So in your textbook, or if you are having a logarithmic table book, you can see in logarithm table book, log 50 is 6990. Okay. So what is log 50? Log 50 is 6990. This is not the final answer. Since there are two digits, you need to subtract 1. 2 minus 1 is 1. So 1.6990 is the answer for log 50. Okay. So what is the log 50 answer? The log 50 answer is 1.6990. So it will be multiplied with 3.322 and it will be added with 1. So the answer, I will be going with the final answer. The final answer is 6.64. Nothing but how many classes we should go with? We should go with 6.64 classes. But okay, it is okay if we go with 6 class, we go with 5 class or else 7 class. But there is no 0.64 classes will not be present. Okay, so that's why we need to approximate it to the upper limit. That is, let us go with 7 classes. So first we found out what is the range. After finding range, next we found out what is the number of classes that we need to go with, that is a k value. So now the third important component is we need to decide what should be the width of the class. Okay, so width of each class. So width is equivalent to, again there is a formula, range divided by k value, that is number of classes. What is range? Already we know the range value is 32. What is the k value? K value number of classes is 7. Okay, so what is the answer now? So here 7 5s are 30. We would like to go with a class width. What should be the width? Width of actually 5. 5 will be better. So here let us go with around 7 5s are 35. So we'll go with around, approximately it will be, let us say not exact value. Let us go with around 5 width. Okay, width of 5. 7 5 is a 35, not exactly. So, let us go with around 5 width. Okay. So, these are the few important things first we need to consider. First, we need to know what is the range, followed by we need to compute what is the number of classes we need to go with, followed by the third important component is what is the width of each class. Always there is an understanding or a principle or rule, it says that always better to go with the width of 5 or 10, but it is now we are going with width 5. Okay, because here 7 4s are 28, we cannot go with 4 width, better to go with 5 width. Okay. Now, let us consider a continuous frequency distribution table. Okay. So, for time being, I am taking all this data off. First, class interval. First is first column, class interval. What does it indicate, class interval? Class interval indicates the weights, isn't it? So, what is class interval? Class interval indicates weights. Weights. How are you going to measure weights? Weights are measured in kgs. Followed by this, let us consider tally marks. Tally marks. The third, followed by this, the third column is number of students, that is number of students, nothing but it is frequency. Frequency. Okay. So, let us start by forming all the classes. So, what is the smallest value? 32 is the smallest value out of all those 50 values. Okay. So, let us start with 30. Okay. We will be considering what is the width of the class. Width of the class is 5. So, 30 to 35. Please understand here, 30 to 35. This is an exclusive class interval. Nothing but upper limit will not be considered for this class. Upper limit will be considered for the next class. So, what is the next class? 35 to 40. I hope you are understanding. So, what is the width? How to find the width? Upper limit of the class minus lower limit of the class is the width. 35 minus 30, that is width is 5. Next, 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65. The highest value among all the 50 values is 62, I hope. Okay, 62 or 64 is the highest value. So, we will be going only with up till 65, that is enough. So, how many classes we had? 1, 2, 3, 4, 5, 6, 7, totally 7 classes. So, according to the Struji's rule also, we got approximately 7 classes. And what is the width? Width is 5. Now, we need to put the tally marks. Okay. So, I will start putting the tally marks. The first is 42. Okay. So, the first data is weight is 42. So, 42 it comes under the third 40 to 45 class, 42 followed by 62, 62 comes here, next 46, 46 here, next 54, 54 here, next followed by 41, 41, 37, 37, next 54 here, next 44, 44 here, next 32 here, next 45, 45, please observe here 45. Here in this class 40 to 45, if even we get 45 as a value of a variable, it will not be considered for this class because upper limit will be excluded. Okay, so we need to consider here 45 here. Okay, so we will be putting all the tally marks for all the 50 values. Okay, students wait for all the 50 values. I will be writing the final frequency. The final frequency will be 2, 6, 12, 14, 6, 6, 4. So, if you add all these frequencies, you will be getting the answer 50. You need to get the answer 50. Okay. So, this is total frequency n. So, now it is easy to understand, it is easy to study and easy to analysis. Okay. Easily you can say how many of them are within the weight category 40 to 45. Easily you can say how many of them are in the weight category 55 to 60. And also if possible you can also say how many of them are above a particular weight, that is using cumulative frequencies that we have not done in this particular problem. Even that can also be computed. Okay. So, with this question I will be ending the video. Thank you.